Welcome to our next level 1 chance and data video. We're going to show you how to use probability trees to solve problems. Right, into example 1, and this is the example we looked in the last video where we had 5 marbles, 3 red, 2 blue. We drew a marble out, we didn't replace it, and we drew a second marble out. Right, here's the probability tree we set up in our last video. There were 4 outcomes, and to work out the probability of each outcome, we multiplied each of the branches to work out the respective probabilities. Now, if the answers are in fractions, a good check is to add up the numerators to see if they add up to 20, which is the denominator. Okay, let's get into solving some problems. Part A, what's the probability we draw out 2 red marbles? Well, the only option out of the 4 is this one, 2 red. We've already calculated the probability, so the answer is 6 chances out of 20, or you might prefer to simplify it to 3/10, 0.3, or 30%. Part B, what is the probability we draw no red marbles? There's one option out of the 4, it's this option here, 2 blue is the only way to get no red, and we've done the calculation already. So the probability of no red is 2 chances out of 20. All right, part C. What is the probability we draw at least 1 red marble? When we say at least 1, we mean either 1 or more. So these are the 3 options where we have at least 1 red. Here are the respective probabilities. And what we need to do in this scenario is add up the options. So 6 plus 6 plus 6 gives us 18 chances out of 20 that there is at least 1 red marble in our 2 marbles. All right, if I was to do this experiment 500 times, how many times would you expect me to get 2 blues? Well, we know the probability of 2 blues is 2 chances out of 20. Let's come back to our expected value rule where we take the probability and times it by the number of trials. We're going to multiply the probability by 500 because we're doing it 500 times. So all I'm going to do is take the probability, I'm going to use the decimal 0.1 and times it by 500 to get 50. So if I was to do this experiment 500 times, I would expect 50 of them to come up with 2 blues. All right, let's move on to example 2. Marita is watching the 6 p.m. news. They claim there's a 40% chance of rain tomorrow. She has an internal first period, so she can't be late. She knows that if there's rain, the bus has a 50% chance of being late, compared to just 20% chance of being late when it's not raining. We're going to work out the probability Marita will be late to school tomorrow because her bus is late. Right, let's start off with the first branch, either raining or no rain. If it's rain, the bus could be late or bus on time. If there's no rain, the bus could still be late or bus could be on time. Because there's a 40% chance of rain, we're going to put that on the branch where there's rain. We're going to put 0.4 because we don't use percentages in tree diagrams. 40% is equal to 0.4. If there's a 40% chance of rain, there's a 60% chance of no rain, so we'll put that on the other branch. There's a 50% chance of the bus being late if there's rain. So let's go to the rain branch and put 50% onto that branch as 0.5. And there must be 50% chance on the other branch. 50 and 50 make 100%. And we know there's a 20% chance of the bus being late when it's not raining. So let's add that onto the branch of the bus being late when there's no rain. And if there's 20% chance, there must be 80% chance of it being on time. Right, now let's multiply out each of the decimals to work out the 4 probabilities, the 4 scenarios. We want to know the probability Marita will be late tomorrow. These are the 2 options where she's going to be late. It's either going to rain and the bus is going to be late, 0.20 chance, or it's going to have no rain and the bus is still late, 0.12 chance. So to work out the total probability of her being late, we just plus those 2 scenarios together. 0.2 plus 0.12 gives us 0.32. There is a 0.32 chance Marita will be late to school tomorrow because her bus is late, or you might prefer to write it as 32%. Great. Thanks so much for watching.